In order to graph this logarithmic function, I'm going to begin by describing the transformation, specifically the shifts I see based on the equation. Then I'll state the domain, range, and asymptote, and at that point I'm going to switch over to my graphing calculator in order to plot some points. To determine how my graph has been shifted, I'm going to look at the h and the k value, which will do what they've always done if you've been watching our other videos or paying attention in class. The h value is the number located within the parentheses. This number will be your horizontal shift, and it will do the opposite of what the graph says. So a -4 in the parentheses actually means my graph is shifted to the right 4 spaces. The k value is the number being added or subtracted at the end, not in the parentheses. This is your vertical shift, and this does what it says, so this will shift my graph up too. Well, knowing that is all I need to determine my domain, range, and asymptote. The range of a logarithmic function is always negative infinity to positive infinity. It'll always go down and up forever. My asymptote then is a vertical line, which means it's going to be x equals. Now, normally it's x equals 0, but anytime you have a horizontal shift, that'll change where that vertical asymptote is located. So all I need to know is what my h value is to determine my new vertical asymptote. -4, we've already said, does the opposite of what it says it will do, so it'll move my graph right 4, so my vertical asymptote now is x equals 4. So let me actually go ahead and get that drawn in, 1, 2, 3, 4. So I'll have this dashed line where my graph will get really, really close to that, but it will never touch it or cross it, kind of like a wall stopping where my graph can go. This also then helps me describe my domain. My domain is going to be from 4 all the way to infinity, from that asymptote on to the right forever. Now I use a parentheses because, again, I can get really close to that 4, that asymptote, but I can't quite touch it. That's about all that I want to do by hand. I mean, I guess there's one more thing I could note. Since I've got a base that's bigger than 1, I know the basic shape of this exponential curve will be something like this. If I had a number less than 1, my graph would go in the other direction, something like that. But to be a little more specific, I'm going to want to plot points. And at this point, I want to switch over to my calculator. I'll show you a couple ways that I can get this equation typed into my calculator in order to find some points to make a more accurate looking sketch.